So Venn diagrams are a great visual for looking at sets and how they overlap or don't overlap in our overall universal set. So when we draw Venn diagrams, typically what we'll start with is a big rectangle, where that rectangle will represent this universal set of everything that we're looking at. And then from there we can start drawing circles to represent these more specific sets. So a most basic Venn diagram, and maybe you've worked with this before, typically looks like that, where we have these overall two sets. In fact, I'll draw with a different color here, of these two sets, and then we have this region where they overlap with each other. But then we have these regions that don't overlap, and then we have everything else out in the universal set. So first thing, let's go through 3 examples here just to get a feel for how these Venn diagrams display. So what I'm going to do is draw some Venn diagrams. Actually, I'll just go ahead and draw 3 rectangles here to represent my 3 universal sets. Alright, in this first one, I'm going to look at these 2 groups. So I'm going to have these 2 circles. One circle is going to represent insects, and one circle is going to represent flies. Now something I need to think about here is, how do these 2 sets work with each other? Do they overlap? Yes, flies and insects overlap. In fact, something we want to think about here is that flies are always insects. We're not going to have any flies outside of that insect circle. So what we'll have here is we'll have our big circle for insects. And then when I draw my circle for flies, I wouldn't want to draw it like this, because that would suggest that there are flies out there that are not insects, which isn't true. Flies would actually go inside here. It wouldn't take up all of the space, because there are insects that are not flies, but all flies are insects. This graph right here is showing the idea of a subset. We have flies would be a subset of insects. In fact, if I labeled these, let's say I called insects I and flies F, I could say F is a subset. In fact, let's use the subset notation of insects. So that's one way that they can display. Let's say I wanted to graph for insects and cats. If I made a Venn diagram with this and thinking about how insects and cats relate, well, in terms of species, they don't overlap. There isn't an insect out there that we would also label as a cat. There also aren't cats out there that we would label as insects. These operate very differently from each other. So let's say I draw my circle for insects. So if I have my set of insects and then I go to draw my circle for cats, they're not going to overlap. So cats would just be their own set separately. So this graph here is a Venn diagram. It's just that there's no overlap between the 2. They don't intersect anywhere. So with that, we call this disjoint. This is going to be a term we see a lot in our, well, not a lot, but it's a term we will see in our probability section, because it's important to know, can both things happen at the same time or not? And in this case, it would be disjoint. Then let's say we make a group for athletes and students. So athletes will have a circle. And then what we could think about is that some athletes are students. Not all of them, but some of them are. Similarly, students, some students are athletes, some aren't athletes. So this thought where for both of them, they could be both or they don't have to be both, that's going to bring through this intersection circle. So that we have these sections here, like in, how do I want to do this? Athletes, so like what's happening over here in this group, in red that I just highlighted there, those are people that are athletes but not students. In here, in the middle, that would be people that are athletes and students both at the same time. So that's your intersection there. And then out here would be people that are students but not athletes. And then keep in mind we still have everyone who's out here, which would be people that are not athletes and are not students. They would identify as neither of those things. So we get these different areas coming through, but it's important to see that we have this intersection here. So this would be an overlapping Venn diagram, or what we could even call this, you might see this term in our probability section, we'd say these are non-disjoint or not disjoint. It's kind of a strange thing when we get into more statistics stuff. We don't say they are joint, we just say they're not disjoint, but it means the same thing. So those are the types of Venn diagrams we could see. Most often we're going to be working with this scenario in C here where there is an overlap of the two. Now this is a case where there are 2 circles, but we could have cases with 3 circles, like dealing with 3 sets and seeing how they overlap or don't overlap. So here what we could see, and we're going to have these 3 types of pizza. There's a pepperoni pizza, ham pizza, mushroom pizza. But something to keep in mind is that we can have these areas of both. So like in the middle here, that area would represent pizzas that have pepperoni and ham and mushroom. All 3 of them are in that area there. If I'm out here, this would represent pepperoni and ham. So it'd have both of those ingredients. And then here would be ham and mushroom. Here would be mushroom and pepperoni. And as we get out here, this would be only pepperoni. Here would be only ham. And then only mushroom. And then outside is none of those. A pizza that does not have ham, does not have pepperoni, does not have mushrooms on it. Alright, and then let's just assume those are the only 3 ingredients that this place has. We have to restrict our pizzas a little bit because there's way too many options. Let's say they're a very small operation and they can only use pepperoni, mushroom, or ham. Alright, so if I wanted to shade in the pizzas that are pepperoni and mushroom, so we want both of those, and just think about how and means intersection when we deal with these. So we want to see where these 2 things intersect with each other. Now what we want to be careful of, so pepperoni and mushroom, you can kind of think of this whole piece here represents the overall overlap of pepperoni and mushroom. However, they don't say anything about ham. So we're going to assume there isn't ham on this pizza. So this is actually covering too much area right here because it's including that bit. So what we need to do is restrict it further. In terms of the area we want to use, it's this area here. In that area is the intersection of the set pepperoni and mushroom while excluding ham. Alright, cheese pizza. So what we could think of this as is we don't want pepperoni, we don't want ham, and we don't want mushroom. So we don't want any of those things. So what that would leave us with is everything outside. So outside there where we don't have any of those ingredients, that would be just a cheese pizza. It doesn't have ham or pepperoni or mushrooms. Just color that in. So that would be outside of those specific sets, but still within this universal set of being a pizza. Alright, veggie, which we'll just assume they're only having mushroom with it, because that's our only mushroom, or that's our only veggie at this place. So no pepperoni, no ham, and then outside there is our cheese pizza, but we definitely want mushroom. So what we're gonna have is a mushroom group and only mushrooms. So that part of the set there, what I highlighted is only mushrooms, it excludes ham, excludes pepperoni, and excludes just the cheese because we do want veggies on it. Alright, and then the supreme, which if you're unfamiliar with ordering off the pizza. Usually Supreme has everything. So this is where we want pepperoni and ham and mushroom. We want all 3 pieces. So that's where we want to look at where do all 3 sets intersect with each other, which is in the middle there. Now with the wordings I'm using here, we could think about what this would look like in our notation using unions and intersections. Like this last one, we've only really looked in terms of 2 sets, but what this would be that intersection of pepperoni and ham and mushroom. So where do all 3 of those pieces intersect with each other? With this veggie one, and it gets a little more complicated with these, but to give you an idea, like the veggie one is that we want mushroom, and we don't want ham, and we don't want pepperoni. So we want to exclude ham and pepperoni, we only want mushroom. With the cheese pizza, what you could think about is in the middle there, if we wanted the area of all of those sets, that's the union of them. Like in the middle there is the union of pepperoni and ham and mushroom. So having a pizza with pepperoni or ham or mushroom is everything that's in the middle there. And I want to exclude that. So something we can use as parentheses with this is I want to take all of that and I want not that. So that I could just switch that to a complement. And then with this last one, it's that we wanted pepperoni and mushroom, which is the intersection of those 2. But we also don't want ham. So we want to exclude that out. With these set notations, there can be more than one way to write it as well. And you can kind of organize it differently with parentheses as well. So sometimes these could look a little different, but still get to the same area of shading. Alright, so let's go back to simpler cases of just 2 sets and seeing how do these shaded areas come up. So for unions, again with union saying one thing or the other or both, it ends up shading in a large area typically. So if we have our 2 circles, if I wanted the union, it would be, okay, we'd want just A, or just B, or both. So it ends up bringing through what's in the circles and kind of combining or adding it all up. Intersection, so having both things, again is more exclusive. It's typically a smaller area coming through. And this is where we want to see our overlap. So if I have my 2 groups, A and B, then I want to see where they overlap with each other. And then this last one is just to kind of show you other ways you could think about finding these, and if we bring in our complement rule, what that'll represent. So, if I have my groups A and B, I want what's in A. In fact, I'm going to show this in a few steps here. So, I want to see where A overlaps with not B. So what I could think of is, okay, not B is a very big area because that's everything outside of there and also includes that spot that's covered by A. So I just shaded in yellow there. That's the idea of not B. And then I want to see where does that intersect or where does that overlap with my set A. So I could see, well, set A and where it overlaps is just here. So that notation gets at this idea of being in just group A. So where does that overlap if we exclude everything that's in B, but if we want to kind of get rid of that universal set area, in fact now I can delete it. Ooh, I deleted too much, but that idea of having just what's in A is that we want A, and then where is that not B? So that we kind of saw with what I did for the only mushroom case is if I want only mushroom, but then where does that intersect with not H and not P? And it would leave us with just that area that has basically one quality, but we have to talk about how the other sets interact as well. Alright, let's try this with 3 groups, and just seeing this notation, how can we get a visual for what the Venn diagram is doing? So, I'm going to draw big circles. And let's see. A, B, C. Alright. So, what you can do is kind of read left to right. So first thing I'm going to do is I'm just going to think about A union B. So having A or B. So I'm just going to go ahead and shade what that would look like, which that's when we have a large area. So I'm going to have everything in A and everything in B. So we have A or B or both. And then what I want to do is see where does that intersect with not C. So basically what I want to do is, I'm just going to kind of highlight where C is, because I want not that. So I want everything outside of that, which basically means I would just start shading to corner, all the way out, covering A and B, and being out there in the universal set. But without going through the work of shading all of that in, I basically want to see that if I did color all of that in, where does it overlap with what I already did in yellow there? And so basically what I'll have is this area. I would have overlap here, and so I'd have that part of A that's not in C. I would also have this area where A and B overlap but are not in C, and I'd have this area for B that is not in C. So I'd end up with this area here, and let me just get rid of my extra markings there. My eraser won't work. Get rid of my steps there, so you have to see those. And even the yellow bit. There we go. Extra line there, but I don't think I can get it to erase it. But this idea of I would have everything in A and B, but I'm excluding C. So at the same time, I would want to take out anything from C, and it would leave me with those areas there. Alright, with this last one here, I have my 3 circles. Alright, A, B, and C. So again, just reading left to right, I want to think about, okay, where do A and B intersect? And I want not that. So A and B, the intersection is here, and I want everything outside of that. So then I would be out here in the universal set, I'd be here in B, I'd have C. This would cover a lot of stuff if I shaded all of that in. But then I want to see where does that intersect with C. So what I could even do is think about, there goes C. Sorry, my erasing function isn't the most precise on this, but there's C. What I could think of is if I just highlight, here is A and B together, and I just want to go with everything outside of that, where do I intersect with C? So what I'd have is my circle C. I want C, but I need to stay out of that intersection area. So with that, I'd end up with everything in C there, just excluding that little piece in the corner there where all 3 intersect, because I don't want to have values from A and B at the same time. I can have values from B individually and A individually, that's fine, but I just want to exclude any cases where there's both. So these can just take some kind of playing around with and practicing, and with that the book has many examples, so I highly recommend going through the reading and just seeing these different cases and how to interpret them.